Recording in progress.
Yeah, comes on everyone. Let's start off. So the last thing that we did, we are doing movement of inertia. And we did movement of inertia for solid sphere. Hope everyone has gone through the notes once. That's important. You need to revise after every class, or else you will forget a lot of stuff. Let's go ahead with one more. This is your x-axis, this is your y-axis. It's a square plate where sigma is equal to sigma naught xy square. Surface density. This is 0, 0. This is a, 0, 0, a. So find moment of inertia about an axis perpendicular to the plate and passing through the origin. Hope you guys remember, we did something like this for center of mass. Others can solve?
मैंने ज्वाइन
Chalo, chalo, Shaurya, settle down. You kept your mic on and you're shouting.
Sorry, sir.
Everyone heard. You're dancing, you're doing tiger dance. We saw everything. Chalo, let's get this thing. Hi, people are missing today. Did you get the question? So the axis is about this line. So the whole plate is rotating in this direction. So find the moment of inertia about an axis perpendicular to the plate and passing through the origin. Let's see how will you handle this. Others, do keep your hands on. I hope you guys remember how did we do the double integration thing. I'll show you the element, then I'll give you some time. Let's try. So at a distance x from here and at a distance y from here, take a small rectangle. So the small rectangle ka width is dx and this is dy. So dm will be sigma into area dx dy. Sigma is nothing but sigma naught xy square. That is your mass. This is your perpendicular distance r, which is root over x square plus y square. So what is moment of inertia? Integral dm r square. That's your moment of inertia, remember? Dm r square, but in the dm you have sigma naught xy square dx dy. Since you have two differentials dx dy, you have to put a double integral, and r square is nothing but x square plus y square. And what are the limits? X ka limits will go from 0 to a, and y ka limits also will go from 0 to a. So now how do you integrate this? Sigma naught is anyway constant, push it out. Integral, bring all x to one side, that will be x dx. Integral, you have x square y square dy plus y power 4 dy. So when you're integrating with y, x is constant, and then you integrate with x separately here. So here the y ka limits will go from 0 to a. Then here x ka limits will go from 0 to a. So in this integral, while integrating for dy, treat x as constant. And I told you the meaning of double integration, if it is like, sigma, if you have I is equal to 1 to n and j is equal to 1 to n, and let's say if you have something like a I j, so put I is equal to 1 and then run j 1 to n. It's like a nested for loop. You have a for loop and inside you have one more for loop. If you have ever written programming there, you must ever wrote a nested for loop. So put I is equal to 1 and then run j ka value from 1 to n. Matlab, this will become a11, a12, a13, a14, a15 and so on. Then put I is equal to 2, then run j1 to n. So a21, 22, 23, 24, 25. You're getting how to do that? So you can run the function like that. So this will be sigma naught x dx. Don't integrate this yet. This will be x square y dx, so x square, and that will be y cube by 3 plus y power 5 by 5. Limits will go from 0 to a. Substitute a value there, we'll get sigma naught integral x dx. That will be x square a cube by 3 plus a power 5 by 5. Now integrate this again. That would be sigma naught integral x cube dx a cube by 3 plus a power 5 by 5 integral x dx. 0 to a and 0 to a. So integrate this again. Sigma naught x cube dx will be x power 4 by 4 a cube by 3. Limits will go from 0 to a plus a power 5 by 5 x square by 2. Limits will go from 0 to a. Actually, I could have given 0 to a and 0 to b. I could make it a rectangle. No, but I hope you got the point anyway. So should I make it a rectangle? Let's make this thing b comma 0 and b comma a. It won't be a big deal. This will simply go to b. This will become b 0 0 b. This will be sigma naught a cube b power 4 by 12 plus a power 5 b square by 10. There, you could have kept a is equal to b, same thing, not a big deal. But the main important thing is this. So when you integrate, you can separate like this. First, you integrate with dy. You could have done the reverse. You can integrate first with x and then you dy. It doesn't matter. You'll get the same thing. But this way of integration is important. Have a look at this. All got the steps? Play with this. So now using this, can you find for this guy? Let's say if I give a rectangular plate, we have an axis passing through the center. This is a standard result. Let this be origin. This is x is equal to L by 2. X is equal to minus L by 2. Y is equal to b by 2 and y is equal to minus b by 2. Find the moment finish of a rectangular plate about an axis passing through the center. Now, you know the result, but this is what I was saying. If I mess up something like this, if I mess up sigma x and y, regular results won't work. So you should know how to integrate. And this would be a standard result. Find the moment finish of a rectangular plate. Let's derive this. The length is L and breadth is B. You can do that. Well, let's integrate this because here also I'll mess up something like this. I'll say it'll be sigma naught x square y cube. So then you'll be done. The only thing limits will change though. Try. You understood how to take that element, right? I want you to get used to that double integration thing. It looks scary, but it is not. It is like doable. You just need to see 2, 3 times and then you'll get the hang of it. Everything becomes easy once you have seen that 3, 4 times. First time is always the difficult thing. Do this, Ishman. You can copy it down later notes so you'll have it with you. So again, same thing. How do we choose an element? Take a small piece here, rectangle, at a distance x, at a distance y. This will be r. So dm will be mass m by lb, that is a mass by area into dx dy. So moment of inertia will be integral dm r square r is nothing but x square plus y square. Y ka limits will go from minus b by 2 to b by 2. L ka limits will go from minus L by 2 to L by 2. this would be, you're integrating y, so that will be x square y plus y cube by 3. Limits will go from minus b by 2 to b by 2. This will become x square b, that will be b cube by 12. It will be L cube by 12 plus B cube L by 12. One LB will cancel, you end up with ML square by 12 plus MB square by 12. Like there's an easy way to remember this. So when you take about this, you can simply treat this thing as there is one rod like this and one rod like this. You take the rod ka length is M and mass B and length L and mass B. So this result is MB square by 12 about the center, and this is ML square by 12. Actually, that's what you're doing when you do double integration. When you put double integration, right, you're like you're running a for loop basically. That's what you did. At a distance x, you kept x constant and then you integrated the entire thing for the y coordinates. Isn't it? So then you started integrating all these things. So then you took x ka another value, then you integrated all these things. You took an x ka another value, integrated all these things. So that is one way to remember this. And if you put L is equal to B, it will become a square. For a square plate, I will be M L square by 6. Standard results, you need to remember them. So for a square plate, about a line passing through the center, the moment of inertia is ml squared by 6. This is for a rectangular plate about the center. All clear with the steps? Check it out. Any doubt, anything you're not clear on this, please ask. At the end, we will put on all the results though. Any doubts on this page? Clear? Let's go ahead. Now, so if you see, right, till now I taught you everything using just integrations and stuff. Now we have two theorems there, which will make your life much easy. And again, we're not going to the derivations. We're just going to put on the results directly. So what parallax theorem says is, if you have any body there, the moment of inertia about any axis, IA will be the moment of inertia about center of mass, parallel axis plus md square. So here, these are the axes passing through. So A and the center of mass must be parallel. That's why it's called parallel axis theorem. And here D is the distance between the axes. 。 There. You should definitely mug it up. So if you have two parallel axes and one of them is passing through the center of mass, then the moment of inertia about A will be ICOM plus MD square, where D is the distance between them. So this will work only for parallel axis, right? You cannot take, A like this and center of mass's axis is some other angle. Then you can't use this. You have to make sure that axes are parallel. Now in this, there are a few things they can ask you. Now looking at this statement, right? Think of like this. Let's say if you have a body there, then the moment of inertia is minimum about which axis? Look at the formula there. IA is I center of mass plus md square. That means the moment of inertia of every axis is I center of mass plus something. For example, see, if I tell you like this, the height, let's say in a class, teacher is there, students are there. The height of the teacher, right? The height of the student is height of the teacher plus distance between the student and the teacher. You can listen to the statement. Height of the student is height of the teacher plus distance between the teacher and the student. Who is the shortest person in the class? Make sense what I asked? The height of any student in the class is height of the teacher plus the distance between the student and the teacher. Who is the shortest person in the class? The teacher, right? Teacher is the shortest guy in the class because everyone's height is teacher plus something. Are you getting that? The same way here, if you see a moment of inertia about A is center of mass plus something, md square is a positive number. That means among all the parallel axes, the axis passing through the center of mass has least moment of inertia. Again, you can compare only among the parallel axes. Huh? Second thing, the locus of all the points with the same moment of inertia. These are like, mains or CET level questions. So if you take few points, they'll have same moment of inertia. So if you join all these points, what kind of shape will you get? So locus of all points with the same moment of inertia. Think about this. Look at the formula again. ICOM plus MD square. That means as long as D is same, you get same moment of inertia. Means from center of mass, all the points which are at a distance D will have same moment of inertia. So all these points will lie on a circle. So locus of all points with same moment of inertia is a circle. So if you have a body there, if this is the center of mass, and then all these points which are equidistant from this thing, as long as you maintain the distance d is same, the moment of inertia will be same. Yeah, these are the kind of theoretical questions they can frame. Right? It's a pretty simple theorem. So let me show you a few examples how to use this. Now, this you already know. Suppose if you take a rod, right, and you want the moment of inertia about any axis, not about the edge. Let's say this is the center of mass and this distance is L by 4. Now, normally what we have to do, we have to integrate this and we have to put the limits minus L by 4 to plus 3 L by 4. Little lengthy, but we can use parallaxes theorem. Let's call this point A. So I about A is I about center of mass. So this is the thing. If you don't know about center of mass, then you can't solve the questions. I center of mass will be how much for a rod? ml square by 12. M, the distance is L by 4 whole square. That's it. Meaning you can actually skip all this integration. That would be 1 by 12 plus 1 by 16. Take out 4 common, you'll get 1 by 3 plus 1 by 4. That will be 7 by 7 ml square by 48. Clear? Let me show you one more. Let's say we have a ring. This time we want the moment of inertia about this corner, meaning it's an axis perpendicular to the plane and passing through the circumference. Now this, if you try to use integration, it is a mess. Because how you will choose an element, the distance, everything will keep changing. But if we use the parallaxes theorem, I about A will be I center of mass. For a ring, what is the moment of inertia about center of mass? Mr square plus m into the distance is also r, 2mr square. Can you see? This thing saves you a lot of time. Matlab, no integration, nothing, you'll get the answers. But you should know the center of mass ka result. If you don't know your standard result, then you can't do the question anyways. Clear? So let's see a few more. Now you guys try. Square plate about the corner. Square plate, mass m, side A. The axis is passing through the corner and perpendicular to the plane. Solid sphere, mass m radius r, hollow sphere. Mass m radius r. Let's get them. Let's see. So whenever you want to use the parallaxes theorem, first thing, ask yourself, where is the center of mass and where is the moment of inertia? This is your center of mass. So this distance will be your distance, which is a by root 2. So I about A will be I center of mass plus md square. For a square plate, the moment of inertia about the center is ma square by 6. We derived it just now. M into d square, that will be ay root 2 ka whole square. This will be 2 by 3 ma square. Remember, that is half diagonal. This thing, for a solid sphere about the center, we know it is 2 by 5 mr square. We derived this last class. For a hollow sphere, the moment of inertia is 2 by 3 mr square. Like I said, for a given axis, the moment of inertia behaves like a scalar quantity. So you can directly add it up. So moment of inertia about A will be 2 by 3 mr square plus mr square. This is for the hollow sphere, plus 2 by 5 mr square. So you are finding each one of them about A, and then you just add them up. 2 by 5 mr square for the solid sphere plus parallaxis theorem mr square, and you're done. Clear how we did that? So find for the solid sphere separately, find for the hollow sphere separately, and then add them. That will be the total moment of inertia about A for that system. Clear with this? I'll leave the calculations to you. So how much you got? 46. Okay, that's 46 by 15 mr square, it seems. You guys can check it out. Let's see one more. This is a square frame made of 4 rods. Find the moment of inertia about this corner. This is 45 degrees. So this axis is in the plane of the frame. Axis is passing through edge through a corner and parallel to the plane. Matlab this line and this square plate are in the same plane. If it is perpendicular, na, I would have given the thing like this. I would have said axis is into the plane. I would have put a cross. The side view would have looked like this. I would have shown something like this maybe. But I hope you got it, the picture. The axis is in the plane. Meaning, you can think of like this. Meaning, if you're looking at my screen now, this is how it looks. So if this is the square plate, I'm catching in one corner. This is the axis. It is rotating like this. Clear with this? What is perpendicular? Perpendicular will rotate like this. That would be different. If this is the square plate, perpendicular would look like this. Clear with this? So it depends which axis. The answers will change completely. So we have to be clear about which axis you're talking about. Let's get this. This is a good one. It's a pretty good mains level question. So there are 4 rods. That is not a square plate. It's a square frame made of 4 rods. Let's see. How do you approach this? Right, Samyak. Nee, Anvita. Nee, Obya. That's not the answer. Right, Siddesh. नहीं श्रीहरि, नहीं आ रही है। नहीं होता। Listen, if you try to do for each rod, it is a mess. Why? If you take for each rod, this is how you have to proceed. Huh? First, find about the center of mass of each rod. So this is the center of mass. Then we use parallaxes theorem. Then for this rod, this is the center of mass. Then we have to use parallaxes theorem from here. You're getting it. That is the distance you should take. And then we have to do 2 times. So yeah, it becomes a little complex. But you can do something more interesting. Instead of this, let's take a line passing through this one. This is the center of mass of the frame, agreed? That is the center mass of the total frame. Instead of taking each rod separately, take the center mass of the overall system. And what is this angle? 45, and this angle? 45. And if you remember, we studied this. If you have an axis and if you have a rod which makes an angle of 45 degrees, do you guys remember the moment of inertia? If this is theta, then moment of inertia about this axis is ml square by 3 sine square theta. याद आया? So these four rods are making 45 degrees. So moment of inertia about center of mass will be ml square by 3 sine square 45. And there are four rods, so into 4. Now remember, parallaxes theorem always has to be used from the center of mass. You cannot shift it from wherever you want. Now you want about this point A, and this distance is L by root 2. Therefore, moment of inertia about A will be I center of mass plus md square. But be careful again. This m is the total mass of the system. So people do goof up, small mistakes, people put that this ml square by 3, sine square 45 is 1 by 2. Total mass is 4m and the distance is L by root 2 ka square. That will be 2 by 3 ml square plus 2 ml square, 8 ml square by 3. Check. See where it went wrong. Maybe here you took m instead of 4m. Or maybe you tried to find the moment of inertia for each rod separately. But if you take the whole thing as one system and take it from the center, it becomes easy. Because when you take about the center, all the four rods are symmetrical. The result is this. Then you use parallaxes theorem. So this is how the questions are. You need to understand, how to take it, which way is more easy and which is more convenient. You might have 2 to 3 methods to do. Some might be lengthier, some are easy. So there's nothing like wrong. Clear with this? All got this? Let's see one more. We have an half ring. Remember this question. This will again come in a simple harmonic motion. This is a 2004 JEE question. Half ring, mass m, radius r. The hinge is here, the topmost point. This is your center. Find moment of inertia about it. The axis of rotation is into the plane. Means, you know how it is rotating? Again, if you look into my screen, so if this is the ring, it is rotating like this. Meaning axis is which way? Axis is into the plane. Na? This is important because see, this now I can rotate like this also. Then the axis will be this way. I can rotate like this also. Then the axis will be this way. Are you getting it? So there are multiple ways you can rotate. So we are being clear here. The axis is into the plane. So you're actually rotating like this. It's like your calendar on the wall. When you slide it, the calendar slides. So here axis is into the plane. Let's get this. This is a good one. Again, there's only one formula we're playing with. I about axis is I center mass plus md square. Both the axes must be parallel. Nee, Srihari, that is wrong. That looks right, Samyak. Nee, Utsa, wrong. That looks right, Arya. Now, the most common mistake what people do. About the center, moment of inertia is mr square. Why? All are equidistant. Then we'll use parallaxes theorem plus mr square. Now the question, where is the center of mass for an half ring? It is not the center. You cannot use parallaxes theorem from wherever you want. So for an half ring, this is your center. This is your center of mass. This is your point. The distance between these two is 2r by pi. And the distance between these two is r minus 2r by pi. So here, I about center we can calculate because you can clearly see all the points are equidistant, which is mr square. In case you forgot, this we did an arc. Remember the shape? For an arc of any angle, mass m and r, it is I mr square. All points are equidistant. So I know about I about center. So I about center will be nothing but I center of mass plus m into distance square, which is 2r by pi whole square. So you have to find I center of mass from here indirectly. Similarly, I about A will be I center of mass. So the parallaxes theorem must be used always from center of mass. You cannot shift from wherever you want. This will be m into r minus 2r by pi whole square. Now I don't want to find I center of mass exactly, so subtract them. So mr square minus IA, I center of mass will cancel. You will end up with m 2r by pi whole square minus r minus 2r by pi whole square. This would be mr square minus IA. That looks like a square minus b square. So I can write a plus b and a minus b. If I do a plus b, 2r pi will cancel. And if I do a minus b, then it will be 2r by pi minus this thing. So it will be 4r by pi minus r. So IA will be, mr square will come this side. That will be 2mr square minus 4mr square by pi. That is the moment of inertia about A. Yeah, you can take out 2mr square common. You will get 1 minus 2 by pi. There, be careful with that. The most common mistake people take I center, they will directly use from the center. You cannot do that. You have to always go from center of mass to any axis. So see if you got the same thing. In case you messed up, see where it went wrong. All clear with this? So be careful with that. That is the only thing you have to be careful. Both the axes must be parallel. Second thing, you're always shifting from center of mass. So if I give you some random point, you cannot shift from there. Any doubts on this page? Clear, na? Devanshi? Shaunak? Vedika? Utsa? Srihari? Rudransh? Perfect. Let's see one more. Let's say moment of inertia is given by 3x square minus 2x plus 7. So this is I is a moment of inertia as function of x. Maybe x might be an x coordinate. There is no other information. What is the mass, body? Nothing is given. Find I center of mass. This is a proper mensural question. Meaning, if you really don't understand exam, you will feel like, what the hell? It doesn't matter. X is whatever it is, Srihari. What is the concept here? Do you guys remember we made a statement? Among all the axes, moment of inertia about center of mass is minimum. So indirectly I'm asking you find the minimum value of this function, maximum minimum. Therefore, moment of inertia of center of mass must be the minimum value of this function. How do you find minimum value of a function? Differentiate it. Di by dx will be 6x minus 2. If we equate it to 0, we get x is equal to 1 by 3. Double differentiate. D square I by dx square. That will be 6 greater than 0. Therefore, at x is equal to 1 by 3, we get minimum. I hope you remember how to do maximum. In case you forgot, you should go back and refer again. So what is I minimum? So I center of mass will be substitute 1 by 3 there. 3 into 1 by 3 minus 2 by 3 plus 7. That will be 20 by 3. Yeah. Easy? But yeah, this is the level of mains level questions. They do are such things. They're not tough, but you need to think a bit. Any doubts on this? There, that's your parallel axis theorem. Now we have a second theorem called perpendicular axis theorem. See, the word itself will tell you a parallel axis theorem. So use this whenever you want to find about an axis and you know moment of inertia about center of mass parallel axis. So if you know moment of inertia about center of mass about a parallel axis, then we can find about any other parallel axis. Perpendicular axis theorem. Again, look at the word. Let's say you want to find moment of inertia about a axis, but you know moment of inertia about an axis perpendicular to the plane or perpendicular to this axis. So then use this theorem. So the word itself will tell you which theorem to be used. So it all depends on which one do you know. Do you know the moment of inertia about an axis which is parallel or perpendicular? But this thing has a issue there. This is again valid only for planar bodies. That means sheets. You cannot use this for 3D bodies like spheres and all. Parallel axis theorem can be used for anything. So be careful with this. Don't use this for spheres and hollow spheres and all. It doesn't work. It's only for sheets. So if you have any random sheet, let's say this is x-axis, this is your y-axis, and let's say this is your z-axis. So what this theorem says is the moment of inertia about this axis is equal to ix plus iy. So let's define what is z, x, and y properly. Iz is the moment of inertia about an axis perpendicular to the plane. So you can call anything as x, y, z. It doesn't matter. This x and y are axes in the plane. And perpendicular to each other. And all these three axes must pass through the same point. There. So how do we use this? So again, like I said, when do you use parallax theorem? I know moment of inertia about an axis passing through center of mass, and you want to find about a parallel axis. Use parallax theorem. I know moment of inertia about center of mass or some axis, but I want to find about an axis which is perpendicular. Then use perpendicular axis theorem. Remember that way, right? When you do a question, you'll understand which theorem to be used. So let me show an example. Let's say we have a disk. Right? And they will ask you find moment of inertia about an axis x, basically like this. So this is an axis in the plane This is an axis along the diameter. Getting it? Meaning the picture will look like this. If you're looking into my screen, so if this was the disk, so the axis is this line, okay? I'm catching like this and I'm rotating like this. You're getting how is the rotation? Suppose if this was the axis perpendicular, then I'm rotating like this, like you know that Vishnu Chakra types. It's rotating like this. This is a perpendicular axis. I hope you're getting the difference. A perpendicular axis will look like this, so then it will rotate in this plane. If I set diameter as the axis, then it is rotating like this. Are you sure, everyone? Right? So we want to find about this. One thing, integration is a mess. So what we do, we look at the theorem. So this is the top view. This is your x-axis. Now, how to use parallax theorem? We will choose one more axis perpendicular to this. That will be y-axis, and these two are perpendicular. Now we know about an axis perpendicular to the plane. Iz, so we know. That to be integrated if you remember. So Iz is nothing but mr square by 2. This came from integration. Now from perpendicular axis theorem, we know Iz will be Ix plus Iy. Right? And due to symmetry, you can clearly see x and y are identical. Because if you see x and y, they are exactly like this. So due to symmetry, Ix is equal to Iy. Therefore, this will be mr square by 2 is equal to 2 times Ix. Therefore, Ix is equal to mr square by 4. There, no integration, nothing. Remember, we integrated only for an axis perpendicular to the plane. We don't know how to do for a diameter. But we can use perpendicular axis theorem and get this. And luckily, right, you can always remember this. Whenever you use perpendicular axis theorem, it becomes always half. Now, let me show you where it will not work. Listen to this example. Let's say same question, someone gave you a triangular plate. Right? And let's say Iz is given. So let's say this is the centroid. So let I not be given. So they gave you moment of inertia about an axis perpendicular to this. We will calculate that also later on. And now it is asked, find about Ix. Great. So what you will do, you'll draw two perpendicular lines, Ix and Iy. Then you'll use perpendicular axis theorem. So Iz is equal to Ix plus Iy. Till here, there is no problem. It is still right. The problem comes here. Ix is not equal to Iy because there is no symmetry. If you see, X and Y are not symmetrical. Matlab, if you cut like this and if you cut like this, you don't get identical pieces. So therefore, the theorem is right. You can still use it, but you can't solve. That's it. You will get stuck. Ix plus Iy is I naught. You can't do anything more than that. You cannot simplify. So this is the main criteria. In order to use the moment of perpendicular axis theorem, Ix and Iy must be equal. If these two are not equal, you can't solve. The theorem is not wrong. Theorem is valid, but it can't be solved because you don't know what is Ix and Iy. So this is the moment of inertia about the diameter. Is this clear, everyone? So now we will use combination of parallel axis and perpendicular axis theorem. So let's see a few questions and let's see how we do that. So be careful with that. So when to use parallel axis theorem? You know about center of mass, you want a parallel axis. Straightforward, done. You know about center of mass and you want something perpendicular. Use perpendicular axis theorem. So let's say we have a disk. Mass m, radius r. We want about an axis parallel to the plane and perpendicular to the passing through the circumference. So the axis is in the plane. And tangent to the disk. It is not this way, okay? If it is perpendicular, na, I would have drawn like this. That would be perpendicular. This is parallel. Let's find for this. Find IA. Hmm. I'll show you two ways, huh? Because now see again, listen to this. So whenever you get a question right, don't jump into solving directly. Ask yourself, okay, fine, you got a disk. About which axis do I know? About a perpendicular axis, I know. Right? That is the thing I know. Great. But are these two axes parallel? No. When I'm doing the question, this is how I ask myself. So we have an axis passing through the center of mass. Right? So I, center of mass, perpendicular to plane. This we know from integration. This is mr square by 2. Great. But in the question, you are asking about this axis which is in the plane. Okay. Are these two parallel? No. Are these two perpendicular? No. These are skew lines. You know what are skew lines? There are four types of lines: parallel lines, lines which are crossing, lines which are perpendicular, lines which are skew, meaning they don't meet, they're not parallel, they're nothing. It's like, for example, the wall in front of you, if you draw a line there, and if you draw a line on a floor, these two lines are skew lines, isn't it? They're not parallel, they're nothing. So if you see, these two are actually skew lines. So how do we go about this? Now there are two ways you can do. One, I can first bring this thing parallel to the plane. So I will use first perpendicular axis theorem, right? And then I will go there. So I'll show you both the things and you will see what happens. So first let's use perpendicular axis theorem. This was just now we did. This and this. So this is x, this is y, this is your iz, which is mr square by 2. So first we are using perpendicular axis theorem because I need to bring it to the plane. Then we can argue iz is equal to ix plus iy. Then this will be mr square by 2. This will be 2ix. This we just now did this thing. So ix is equal to mr square by 4. Perfect. Then now I know about an axis which is passing through center of mass. Right? And now you want about a, now these two are parallel. So I can use parallel axis theorem now. You're getting the catch. You have to bring it to parallel to use parallel axis theorem. Initially it is not parallel. So I about a parallel to plane must be I about center of mass. Again, be careful. This also must be parallel to plane. You can't add perpendicular to the thing. Plus mr square. That will be mr square by 4 plus this 5 mr square by 4. That's your answer. Clear. Now I have another way of doing. Listen to this. But any doubts on this page? So I used perpendicular axis theorem. Then I used parallel axis theorem. So I have to use both the theorems back to back. Now see, I'll do something else. This will be the another option in the thing. Most of you got right though, but I know about this axis, IZ. So I perpendicular passing through center of mass mr square by 2. This I know from integration. So this is my idea. First I will use parallaxis theorem. So I'll find IA perpendicular will be I center of mass perpendicular plus mr square. That will be 3mr square by 2. Then now I know about IA perpendicular. I will draw two lines here perpendicular to them. This is your x and this is your y. Now I will use perpendicular axis theorem. And then I will say Iz is equal to Ix plus Iy. I know Iz is 3mr square by 2. This is equal to 2Ix. I will get Ix is equal to 3mr square by 4. But this is giving 5mr square by 4. Someone is wrong. Who is wrong? And what is the mistake? So here, first I used parallel axis, then I used perpendicular axis. In the previous one, I used perpendicular axis, then I used parallel axis. Technically, I should get the same answer, but I'm not getting. Something is wrong. Which one is wrong and what did I do? You can type Narayarya. If you wanted to say the answer, type unless you have something else. Ah, right, Samyak. Right, Arya. Nee, re Srihari. As if this is not a 2D figure, kya? What you're saying, God? Yeah, the mistake what I did was this. यहाँ पे Ix is not equal to Iy. They're not symmetrical. No, if you look at the shape, this is your Ix. This is your Y. Do they look same? They're not symmetrical, right? For X, look at the shape. For X, it is half and half disk. For Y, it is like this. Do you guys still think they're same? They're not same. So the problem is Ix plus Iy is M3mr square by 2. That is true. That's it. You can't solve. So that is the reason this method won't work. Are you getting it? So parallel and perpendicular won't work here. Now, how do you know which will work, which will not work? Unfortunately, you can't do it. You have to try both and hit and trial. Whichever comes first, that will work. Are you clear with this? Because some people do this and that option will be there in the exams. You should have an idea that what is the wrong with that. Clear? Not a tough question, but yeah, people do get confused. So it is not always about knowing the right things. Huh? You should always have an idea about what mistakes you can do. That will keep you, very alert in the exam. Let's see one more. This is a good one. We have a square plate. Mass M and side A. This is your center. We have an axis passing through the center. And this thing makes an angle theta with the horizontal. Axis in the plane and passing through the center. Find the moment of inertia. Same thing, axis in the plane, but this time it makes an angle 15 degrees. Let's get both of them. Hmm. Square is an interesting shape. Calculate करना रे आर्या. What kind of answer is that? Simplify करना. हाँ श्रीहरि. That is right. नहीं होता. That is perpendicular to the plate, नहीं होता. This is parallel to the plane, ना. नहीं रे आर्या, that is wrong. Look at the first one, huh? Like I said, square is an interesting shape. If you take a square plate, so let's say you have a chocolate in the shape of a square. You and your sister want to share. And the square is a very interesting thing. As long as you cut through the center, you cut however you want. But as long as you pass through the center, you always get two equal pieces. Can you see this thing? This piece and this piece, they're same, isn't it? You're getting it? The two pieces are always identical. You can see this is a line of symmetry basically. Both sides are identical. Look at this. This point, this is the perpendicular distance. This point is the perpendicular distance. If you take this point, this is the perpendicular, this is the meaning exactly they'll have all same perpendicular distances. Right? That means if I draw one more line like this, perpendicular to this, that is also a line of symmetry. So in a square plate, if you draw any line passing through the center, they all are identical. Now I can use perpendicular axis theorem. So I perpendicular passing through the center of mass will be Ix plus Iy. This is your x, and let's call this thing y. So this is m l square or ma square by 6. We calculated this. And since Ix is equal to Iy, there is a symmetry. They're identical. So we get 2Ix. Ix is equal to ma square, but independent of theta. It doesn't matter. As long as you pass through the center, it will be always the Monte Fenicia same. Is that clear, everyone? That's a pretty good result to remember. So if you take a square plate, if you say it is passing like this, I1, if you are passing like this, the diagonal, I2, you're passing at a random angle, I3, it doesn't matter, all are same. I1 is equal to I2 is equal to I3. This does not work for a rectangular plate, huh? Square plate it works. Any doubts on this? Right, Samyak. What about the B part? Go, take a break, come back in 5 minutes. We'll continue after this. That's a 15 degree. So take a break, come back in 5 minutes. Get away from the screen. There it is wrong, Srihari. Chalo, cams on everyone. Let's start off. So, how do we do the second part? Most of you are doing this mistake. The perpendicular distance you're goofing up. So, first take a line passing through the center since you're taking 15 degrees. Remember, to use parallaxis theorem, you need a line parallel to this axis. So, I will draw a line passing through the center of mass, which is also making 15 degrees. This distance is a by root 2. That is great. But who told you that is perpendicular distance? That is not the perpendicular distance. Are you getting it? So when you drop from here, if you drop a line from here, this will be the perpendicular distance. This angle is 45 and this angle is 15 degrees. So if I call this thing A, C, and this is B, if I draw the triangle, you can clearly see now A, B, and C. The BC is the perpendicular distance. This angle will be 60. This D is the perpendicular distance, and this is A by root 2. So BC will be A by root 2 sine 60, which will be root 3 A by 2 root 2. That's your perpendicular distance. So I about A will be I center of mass plus MD square. I center of mass just now we derived. It is independent of theta. This will be M into, this will be 3A square by 8. That will take MA square by 8. Then MA square by 24. That's the thing. Clear with this? The mistake is you thinking A by root 2 is a perpendicular distance. A by root 2 will be perpendicular distance when? When the angle is 45, isn't it? If this axis is making an angle 45 degrees, then it will be perpendicular, na? The 15 degrees won't make it perpendicular. Are you clear with that? And most of you got that 7 ma square by 12. That would be one of the option in the exam. So be careful with that. So here BC is the perpendicular distance. Clear? Let's see a few more shapes. Any doubts on this? Let's say we have an arc disk, mass m, radius r. We have an axis passing through the center and in the plane. Solid hemisphere, half of it. Mass m r solid hemisphere. Find I. What would be the first one? C. Remember the statement? As long as you keep the perpendicular distance same, it doesn't matter how you arrange this. So what I will do now, look at this. Suppose if this was my half desk, suppose if this book is my half desk, right? I will just, slice it like this. I will make it open up like this. I will exactly cut it in half, right? If I do that, what do you think will happen? So if I cut it like this and if I open this, won't it become a full disk? You're getting it? If I just slice it and if I open this, it will become a full disk. And how will this line look like? The line will look like passing through the center, right? And you can actually see the symmetry here, say. This is theta, this is theta. So what I will do here, let's call this thing as point. So if this was point A, if this was point B, so this was point A. So you will get an identical point here, point A. If this was point B, you'll get an identical point here, point B. And can you see the distances? This distance are same. This distance and this distance are same. So by opening the disk into half, did I change the perpendicular distances? No. The mass distribution is looking identical. That means the moment of inertia of the half disk is same as the moment of inertia of this full disk. Is that making sense? Are you getting how did I open this? So this is what you do. Stretch this into a full disk. Now, some people, right, they do like this. They will say, let's put one more disk. You can do that, nothing wrong. But then the mass will become 2m. So when you use that parallaxes theorem, right, people forget that 2m and they'll put m only and then everything goes up. Bolo Nadia.
Sir, another way I thought about this was I took that specific sector of theta and I put it in the cavity on the top side of that, like
वही किया है
above
ना तुमने
axis.
मतलब you took this thing kept it here, you took this thing you kept it here, full disk बन गया.
Yeah. No, I didn't make
हाँ,
the full disk actually. I just
okay.
completed the half disk with the extra remaining portion that we have got.
वो भी सही है. That is also right. Same thing. End of the day, we have to make it into something symmetrical. So stretch this into a full disk, and we observe the perpendicular distances do not change. So therefore, for an half disk, it is same as, so this is the diameter. So this question has become like you got a disk and you're asking find moment of inertia about the diameter. And this result we already know, mr square by 4, independent of theta. What Arya said was also good. He's saying take this piece here and put it here. Now this becomes a beautiful half disk which is passing through the diameter. You can say it will be equal. That is also good. Whichever you are convenient with. This is independent of theta. The same thing here, I can do the same argument here. What I will do, I will make this into a full sphere like this. So if I take this as point A, this also will be point A. So basically you made this into m by 2 half disk and m by 2 half disk. So mass is still same. So this has become like a full sphere of mass m and r. Through the center, I center of mass we know 2 by 5 mr square. We can use parallaxes theorem. So IA will be I center of mass plus md square. 7 by 5 mr square. Is that clear, everyone? Now just be careful. Huh? You can't do this if the shape is like this. Suppose if this was there. Now if I make this into a full sphere, do you think the distances will remain same? You messed up the distance now. So this you can't do. That doesn't work for this. You can't open this, but you can do this. So when you make it into a full sphere, make sure the perpendicular distances don't change. So how to do this question? This is that half ring wala question, yaad hai? It is like that. We have to use that parallax theorem and solve. This you can't do. Up and lower half are not symmetrical. Clear with this? So there you're playing a little with symmetry there. Let's see one more. This is a good one, right? They did ask in mains also. This will be a direct result in the exam, but let's see how to derive this. We have a solid cylinder and the axis is passing through the center of the cylinder. Radius is r, L by 2, mass is m. This is a thick rod basically, meaning think of your water bottle. Meaning if you look at the side view will look like this, na? Axis is like this, side view say. Find the moment of inertia of this. The result is more important. You should definitely mug it up. Examine the result itself is a question. I think 2018, 19, I don't remember the year, there was a question like this. For a cylinder of given volume, right, find the value of R by L for maximum moment of inertia. So they framed something like that. Let's get this moment of inertia. नहीं Srihari. So let's see. There is an easy way to remember the result also. I'll show you that, but let's see how to derive this. Near Sudesh. There's a goofing up one part though. And listen to the derivation, because tomorrow you won't be so lucky. They will say the density is changing. They'll say rho is equal to rho naught, x square or something like this. Then you should know how to integrate this. Sure, I'll give you another minute. Solve. Let's see. So from the center, at a distance x, take a thin disk whose thickness is dx. So we have a thin disk whose thickness is dx and the radius is r. So the volume will be pi r square into dx. So mass of this thin disk will be total mass, which is m by pi r square L into dv, which is m by L dx. For this thin disk, if you take the moment of inertia about the diameter, which will be mass of that disk into r square by 4. This we calculated. So I know the moment of inertia about this thing. But you want to find about the center. So for this thin disk about the center of mass, right, about the center will be I disk about its center of mass plus mass of that disk into the perpendicular distance square. Are you getting what I'm doing? So I am finding moment differential of this thin disk about this axis, then I'm going to add all of them. That will be m disk, which is m by L dx r square by 4 plus m by L dx into x square. This is the moment of inertia of the thin disk about this thing. Right, area. And then you're done. So integrate for this. So I of that cylinder will be integral mr square by 4L dx. Limits will go minus L by 2 to L by 2. M by L x square dx. Limits will go from minus L by 2 L by 2. That would be mr square by 4. And this will be ml square by 12. So there is a very decent way to remember this result. Again, for symmetrical thing. So this cylinder can be treated as a rod plus a disc. So it's like when you compress this, you'll get a disc. When you just compress in the other direction, it becomes a rod. This is ml square by 12. And for a disc about the diameter is mr square by 4. There. Clear with this? Because the length x and the radius are perpendicular to each other, they're independent directions. You can do this. So generally, this will always work. If you have two perpendicular directions here, right? In this case, the radius, the disk is in YZ plane and the rod is in x axis, so they're perpendicular. You can always do that. You can compress them in the two perpendicular directions and finish it off. But clear with the integration? The integration is important because tomorrow they will ask something of this sort. They will say the density rho is equal to rho naught x square. Then you should be careful. Any doubts on the steps? Please ask me.
Sir,
Hmm.
so how did you like express the moment of inertia of all the disks as mr square by 4 in the next slide?
I'm just saying result ऐसे दिखेगा.
Acha, is there any like logic about behind the result? Like
You
how
are
that?
doing like this thing, na? You're shifting. When you compress the whole thing, exactly logic मतलब वही होगा. So you're trying to find all these moment of inertias. ऐसा सोचो ना. What we did for all the disks. What is the moment of inertia? You're writing this term, na? I about diameter. That is all same for all of them. Plus the second term will be that md square ka term, na? So this has become simply like a disk ka formula only, na? I about the diameter, and this is becoming the rod ka formula. Mathematically, if you see, na, it splits up into two pieces. Because if for every disk there are two parts, na? I about the diameter. This is anyway constant for every disk. वो तो सब add हो जाएगा when you're integrating. Plus the second term has become simply dm into x square, means you treated this like a small piece on a rod. Getting it? Because when you took the dm, you didn't care whether it is a disk or a rod or anything. You just took it as a particle there. The integration goes off like that. Clear? Let's see one more. But that result is quite important. Should definitely remember this. In some exams, that result itself is a question. What if we have a solid sphere with a cavity? There, cavities, I told you. Line passing through the center. Again, remember, this is a solid sphere. Technically, you should not be able to see the cavity. But there, I am showing it. This is a solid sphere with cavity. The cavity is touching the center and the circumference. So the diameter of the cavity is r. Rho is the density. Find the moment of inertia about the center. मास स्क्वायर बाय 20 इतना अच्छा आंसर आ गया रे नहीं रे यार ये हाँ राइट सम्यक राइट सिद्धेश नहीं श्रीहरि your dimensions are not matching श्रीहरि नहीं रह गया थोड़ा बड़ा हो गया let's see so do you guys remember what I told you whenever you see a cavity whenever you handle cavity problems fill up the cavity right so this right you can say so or you can do like this let's take a full sphere because I know how to find the moment of inertia of full sphere minus remove the cavity then this should give you this so you can do this also you can subtract it now be careful here huh? You want to find moment of inertia about the same axis so we want about this axis we want about this axis and we want about this axis you can add them only about the same axis you can't add about whatever axis you want so this guy will be how much 2 by 5 mr square but this guy now remember this mass is m and r this mass will be m by 8 and radius will be r by 2 in case you're wondering how did I get this because we know mass is nothing but rho into 4 by 3 pi r by 2 whole cube so this actually becomes m by 8 but remember I want about the red line okay so the moment of inertia about this line I have to use parallaxes theorem 2 by 5 small m r square will be small m that small r square that's your parallaxes theorem there this will be 7 by 5 small m r square but what is small m by 8 and what is small r by 2 whole square clear with this so what's your final answer so I about a will be 2 by 5 mr square minus 7 by 5 mr square by that is 32 take out mr square by 5 common you end up with 2 minus 7 by 32 that is 64 minus 7 57 32 5 is 160 57 mr square check got the thing so you have to be careful you are subtracting about that red line right but for the small sphere you have to find about the green line then use parallaxes theorem you cannot directly get the red one yeah next one any doubts on this definitely check this out stuff again let's say we have an equilateral triangular plate mass m side a O is the centroid find a moment of inertia about an axis and I about the centroid perpendicular to the plane let's see how we'll do this Chalo, everyone should try. Manchika, clear with the question? Let's go. Advai? Pratyasha? Clear? Shaurya? How do you handle this? How do we approach this? Listen, there is a way to do this without integration. So symmetrical shapes, right? So this is all symmetry, there are techniques. So before jumping into that, if you take linear objects, like a rod or something, we know I is proportional to m in L square. And we know mass is also proportional to length L. That means mass is proportional to L cube. That means if you take a rod of length L, and if you take same material rod but length 2L, if this moment of inertia is I, then this moment of inertia will be 8I. If you take planar bodies like sheets, I is proportional to ml square. For the sheet's mass will be proportional to side square. So this will be L power 4. That means if you take a triangle, and if you take a bigger triangle, let's say if this side is A, and if this side is 2A, so if this moment of inertia is I, then this moment of inertia is 16I. About the same axis or centroid or whatever. If you take 3D bodies, I proportional to ml square, mass is proportional to L cube, m is proportional to L power 5. So if you take a small sphere and if you take a big sphere, if this radius is r and this radius is 2r, if this is I, then this is 32I. Clear with this? So just we are just getting the proportionalities there. So depending on the height of the body. So how do we handle this? So let's say the triangular plate of side A, this is the centroid. Let's say it is given. Let the moment of inertia about the centroid be equal to I naught. We need to find I naught. Now, if you take a bigger triangle, equilateral triangle, but this time I'll take side 2A. Now, the I about the centroid, so I will write like this. So I for this bigger triangle will be 16 times I naught. Agreed with that? Just now we showed that. If you take a triangle, similar triangle but a bigger side, the moment of inertia becomes 16 times because mass will become 4 times and side has become 4 times. Now, Now we can do something interesting. This big triangle is actually nothing but four equilateral triangles. If you join the centers, you will notice there are four equilateral triangles. This is the center one, center two, center, let's call it O, and this is center three. So that means I can split this into four pieces. One piece here, and this is one piece here, and this is one piece here. Like this. You got four pieces basically. So this guy is already at the center. Great. Now, if you look at this, this is the perpendicular distance agreed at D. This is the perpendicular distance D. This is the perpendicular distance D. So what we're trying to do, we will try to find the moment of inertia for all these triangles about the center O, and then we'll equate them. So if you try to find moment of inertia for any one of them, let's say I1 about O, that will be I naught, because about the centroid it is I naught, that's what we got, plus the perpendicular distance will be md square. And what is that d? Hope you guys remember, in a centroid, the distance d will be how much? In case you forgot, I'll write that also. So from the centroid to this distance will be a by 2 root 3. It will divide into 2:1 ratio. So d ka value will be a by root 3. So this will be I naught plus m into a square by 3. This is for one triangle about the centroid. So the moment of inertia of the big triangle will be nothing but I1 plus I2 plus I3, these three triangles, about O plus IO, because that is anyway in the center. And how much is this then? This is I naught plus MA square by 3 into 3 times plus I naught, and the big triangle is nothing but 16 I naught. That would be 16 minus 3, 12 I naught is equal to MA square. That will give you I naught is equal to MA square by 12. Where I naught is the moment of inertia about the centroid. Are you clear what we did? Again, I'll explain. So listen what I did. So for the small triangle, I said let it be I naught. When I took the big triangle, about the center, it is 16 I naught. Agreed? But the big triangle is nothing but four small triangles. So for this triangle, about the center is I naught. Agreed? Because there's a side A. From here to here, when I use parallaxes theorem, this will become I naught plus m into d square. And d is nothing but a by root 3, that will be ma square by 3. Similarly, for this triangle, this is also I naught. So when I use parallaxes theorem, this also will be I naught plus ma square by 3. For this triangle is also I naught. When I use parallaxes theorem, this also becomes I naught plus ma square by 3. That means for these three triangles, when you shift them to this center, it will be I naught plus ma square by 3. And the fourth triangle, which is in the middle, that guy himself is I naught. So now I'm saying this guy plus this one plus this one plus this one must be equal to 16 I naught. Is that making sense? Because when I add moment of inertia of all the four triangles, I should get moment of inertia of the big triangle. Are you sure with this? So there, no integration, nothing. So you can use symmetries and play around like this. So use parallaxes theorem and symmetries. Yeah.
Sir, I followed a completely different approach. What I did was I took the base any one side, and then I wrote it as ICOM plus
You
A by
try to use
root 3
parallaxes theorem.
and then I
कर
use
सकते,
perpendicular axis theorem.
बहुत लंबा है but कर सकते.
Sir, but I
Meaning
didn't
you,
get the answer. Like,
because you messed up somewhere. You need to
most
find out
probably.
this one and this one. ना ऐसा करना है.
Yeah.
How did you get this one?
Sir, I got because we know that it's mh square by 3 about the base.
Hmm.
So I did parallaxes between COM and the
Then yeah,
base.
आएगा. Then how did you do this one?
For two triangles, similarly. mh square
mh
by
square
3
mh
for.
square. आएगा आंसर. कैलकुलेशन बुक अप किया होगा. चेक करो एक बार.
Okay, sir.
आना चाहिए. You're not wrong. That is one way to do. Clear with this? Any doubts on this? It's a very good method. So remember this. So this is also how you can do problems sometimes. So you can use integration, you can use parallaxes theorem, you can use perpendicular axis theorem, or you can use symmetries. The next thing is, this is just a statement, radius of gyration. More than a concept, this is actually a thing in a lab. Think about this. When you go to a lab and there's a solid sphere and you're doing an experiment, who the hell will remember moment of inertia of all the values? Right? The experiment person will go mad and said, like, who will remember all these things? So to make your life convenient, this is what they do. So we define something called radius of gyration. The meaning is the distance at which the total mass must be located to get the same moment of inertia as the system. So moment of inertia of the system is simply m into k square. I'll tell you what it means. So what they do now, when there is a body there, on top of the body, they will print mass is 1 kg, radius of gyration is 2 meters. So what is moment of inertia? Mk square. I don't care what is the body. Then how will you print what is the value of k? So the manufacturer who manufactured it, for example, if it is a disk, so you want to replace this entire disk with a particle of same mass and you want to keep it at a distance k. So what is the moment of inertia for a disk perpendicular to this thing? Mr square by 2. This must be equal to mk square. So the radius of gyration of a disk is r by root 2. Are you clear? So what happens whenever you have this disk, the manufacturer, what he will do, he will calculate the kk value and he will print kk value on top of the disk. So when you go to the lab to do the experiment, you'll see the disk. On top of it, it will be written mass ka value and k ka value. So you don't need to worry that moment of inertia of the disk is mr square by 2 and all that. You can simply say mk square and you're done. This is the radius of gyration of the disk. That's it. This is something more of a lab oriented thing than a concept. For example, if you give you a hollow sphere, so you want to replace this entire hollow sphere with one mass m at a distance k. So 2 by 3 mr square is equal to mk square. So radius of gyration of a hollow sphere will be 2 by 3 r. Are you clear what is radius of gyration? So if someone asks you in the exam, find radius of gyration, just find your moment of inertia and say equal to mk square. Clear? So this is something more of a convenience so that you need not remember the moment of inertia values when you're doing an experiment in the lab. Any doubts on this? That's your radius of gyration. Next thing, let's put on all the values. So if you take a rod, so passing through the center, ml square by 12, passing through the corner, ml square by 3, making an angle theta, ml square by 12 sine square theta. You should mug up these results. Exam mein, you will not get time to derive all these things. Ml square by 3 sine square theta. The rod is parallel to the axis. Md square. arc, mass and radius are. The ring, hollow cylinder. All these three will have mr square. Sector, disk, solid cylinder. This is mr square by 2. So we have a disk here, mass and radius r, or an half disk, mass and radius r. If a line is passing through the diameter, it doesn't matter. So the moment of inertia will be mr square by 4. Rectangular plate, m l square by 12, mb square by 12. If you make this into a square, or if you take a square plate and put about any axis passing through the center, this will be ma square by 6, ma square by 12. This is 6. This will be ma square by 12. Solid sphere, hollow sphere, triangular plate. Solid cylinder. Now cones we didn't do, but you can derive this. Hollow cone, so passing through this 2 by 3 mr square, passing through the center 2 by 5 mr square. If this height is h, I about the base mh square by 6. Passing through the center ml square by 12 plus mr square by 4. If they ask you about the edge now, then it will be ml square by 3 plus mr square by 4. Just like a parallax theorem there, you can do that. For a hollow cone, it is mr square by 2. You have to take rings and interior this. This will be 3 by 10 mr square. That's a solid cone. It doesn't depend on the height edge. Then we write this thing now, equilateral plate. Ma square by 12. Now again, these shapes, mostly they shouldn't touch, but let's say we got a ring. These are mostly out of portion there. The axis is out of the plane. So the axis is passing through the center, but it is making an angle. This will be mr square by 2, 1 plus cos theta. So this is not perpendicular. This is not in the diameter. Mr square by 4, 1 plus. This is cos square theta. So mostly these two results, they shouldn't ask you, but just in case. And other than this, there is one more theorem there which gives you good results, but we'll not do the proof. We don't need it. So if you have a triangular plate, you can actually use this for any polygon. What this theorem says, that entire plate replace with mass is m by 3 at the center. Let the distance be r1 and let this distance be r2 and let this distance be r3. So replace the triangle with m by 3 at the center of the sides. And then the moment of inertia of this plate will be m by 3, and then you take the perpendicular distance r1 square, r2 square plus r3 square. This is valid even for a polygon. If you take an n-sided polygon, then you'll divide the whole thing into m by n mass, and then you'll keep at the center of the sides, and you take the perpendicular distance. We don't have the proof for this, but there is a theorem like this which works for only triangular plates. Clear with this? So mostly if at all there's something of this sort, they might explain you and ask you, but yeah, do remember. That is about moment of inertia. So we saw how to reduce integration, parallel axis theorem, perpendicular axis theorem, and we saw symmetries. And these are all the results you need to remember. So next class, when we catch up, we are going to do the no slipping condition. Like I said, that's the third part. There are three parts: moment of inertia, torque, and no slipping condition. So no slipping condition is a little small one. And after that, we'll start off with the problems. Now things will move. So till now, we are done with the basics. It's like before cooking, cutting the vegetables. So we have cut all the vegetables and we are ready to cook now. Right? Just give me a minute. Let me take the attendance. People left for some reason. I don't know why. These people think they can just leave, and I'll just call them and ask them what's the reason. Yeah. Okay, then with that, we'll wrap up for the day. So I'll see you guys again on Thursday. We'll continue from here. So any doubts, anything else, please stay back and ask, or else you're free to